Alright guys, so here we go. We're going to get started with wiring up this motor, if you will, for our first wheel spin. This is one of the kind of rites of passage or one of the stages. Before we get to this part, what I suggest you do is you get it running on the floor of your garage. It's what we call a bench test. These transmissions are probably too heavy to lift on your workbench or your test bench. So we technically do it on the floor, but that's the first thing. You just make sure all your wires are crimped right and spliced right and connected right. Wiring harness is thinned out correctly. And you get that transmission spinning, you know, it's your first spin, and you do that on the floor of your garage before you even install it. Then once it's installed, everything should be plug and play. So we'll see how well I did on my connections and such. I'm going to start off by connecting all the high voltage stuff, all this orange wires. There isn't that many, okay? I believe this one here is from MG1. We actually don't need to connect this one. We're going to keep it so simple in this video. We're only going to use MG2. One of the reasons is that I haven't locked out the input shaft yet. We will talk about that later. I've talked about it in a prior video. If you lock out the input shaft, that means MG1 will help MG2 spin the rear wheels. This here on the driver's side goes to the front motor in the transmission, which is MG1. I'm not even going to connect it. I decided I'm not even going to bother with this. We're just going to hang here. So I know you can't see me, but I'd rather you see what's being done here than my mug. So I'm just going to use the battery trays as an inverter tray. This is temporary. I didn't even make an inverter bracket yet. That's okay. All right. So this is our inverter, and on the Lexus, it also served as a boost converter. It would take roughly the 280 volts and boost it all the way up to about 600, 650 volts. Momentarily, you didn't drive around on 650 volts, but you had it there maybe when you needed it. It sat right where those holes are here. What on this truck would have been the AC unit. I'm thinking of mounting it more in the center. That's getting ahead of myself. But basically, you would find it on American cars on the passenger side. I believe it was the opposite on you know, the vehicles like in England where they drive on the correct side of the road. Anyway, I'm just going to set it down here. Wow, fits like a glove. Looks like that gives me the illusion that it's off center, but oh well. Now there aren't really that many connections. When it comes to the high voltage stuff, there really aren't that many connections, especially in this video. We're going to keep it really simple. Now, label these before you even start. Label these before you disconnect them. If the wires come plugged in, because they're opposite than the way they're on the transmission. MG1 on the inverter is on the passenger side. On the transmission, it's on the driver's side. MG2 on the inverter obviously is on the driver's side, and conversely, it's on the transmission's passenger side. So, am I doing this wrong already? Just like that. So what we've done now is we've connected high voltage from the inverter to the transmission. That's essentially 50% of it already. Now let's do the other part. Okay, so we are pretending that this is our high voltage battery pack. This is great for testing because we don't need a pre-charged circuit. We haven't discussed pre-charged circuits yet. I honestly think it's an advanced topic. It's something that I understand is needed. I understand what it does. I'm still not fully confident I grasp the entire concept of it, of why it does what it does and why there aren't other safety measures that can be taken. But anyway, this here represents our battery pack. Let's see here. So obviously this plugs into the wall. The guts of this thing look very similar to what you would see inside of your computer, okay? It's a 300 watt power supply in there. It's going to supply 30 volts and 10 amps for 300 watts, okay? This will just plug into the wall, and these ends, which are really red and black for plus and positive and negative, will connect to the back of, or the side of this inverter. Now, what we're doing here is a trick, okay? This is not where it plugs in on the stock implementation, all right? It plugs in actually to the booster converter, and then it's supposed to get boosted, but they're not supplying 360 volts like we will. So we're bypassing the booster converter and we're tapping into what are called the bus bars, the high voltage bus bars. There's a positive stud here that I've screwed in and a negative. So it's safe to connect these because this isn't plugged in yet. Okay, and I'm just showing you guys, I'm just trying to show you guys what is going on here. Let me see if I can. I'm going to turn this around so you can see this as a demo, as I say. Demonstration purposes, all right? So that's what we're doing. What I want to show you guys here is that I went out and I purchased the Lexus battery wiring harness, okay? This plug here on a Lexus actually plugs in right there, just like this. But we don't want that. We do not want to plug in here. And this other one, this other plug here is for the air conditioning. On electric cars, the air conditioning usually is powered through AC or electricity. So as I was saying, on this side you would plug in the electric air conditioning unit. On electric cars, the AC is usually powered by electricity, so that when you're stopped and the engine shuts off, the gasoline engine shuts off, you still get AC. Or when you're just running on electric power, let's say on the Chevy Volt, when you're just in full-blown 100% electric mode, or even on the Prius, it may only be for 7 or 10 miles, you will still have air conditioning because your air conditioning is powered with electricity instead of the engine. Okay, so at this point, if you imagine, we have a battery pack that connects using orange cables to the inverter. The actual battery pack would have a pre-charged circuit in it, like an intelligent switch, if you will. contactors or high voltage relays inside of it, and it would not be live, it would not be on, and it would not be supplying voltage electricity through these wires to the inverter until you start the car. But we're bypassing all that for now. We're keeping it super simple, but still, this is currently unplugged. It's also turned off, so we are not sending any electricity here, okay? But on the actual implementation, all this is permanently connected. There is a mechanical electronic switch called the pre-charge circuit that turns on electricity from the actual high voltage big battery pack and sends it to the inverter. Okay, so usually there is no electricity here until you turn on the car. Okay, so this is really everything that gets high voltage. Our controller, our little logic board, doesn't get high voltage there. And especially for this test, our throttle doesn't get high voltage. That runs off of simple car battery 12 volts. So this is it for high voltage. I'm going to wire up the low voltage next. Okay, so we've connected our high voltage, and now this is kind of the power. This is the muscle connection. Now we're going to turn to the brain, if you will, the logical connection. Yes, it's still electricity, but it's only 12 volts, even less, 5 or 3 volts for certain components. So we need a brain. If this is our muscle, we need a brain to control that. So I'm going to bring out Damian McGuire's and the folks from Open Inverter controller. He calls it a VCU, for Vehicle Control Unit. So I'm going to get that next. Okay, so as I make this video, okay, this is his, it's called the version 2 VCU, and right now as I'm making this video, it's early in 2022, and it's significant I tell you that because I bought this last year, and this was one of the last units. I think after I bought this one, there may have been one other one left, and he makes these in lower quantities, but he changed to a newer model of the brain of the logic board called the Zombieverter, and this is from the generation where this will only work really with the Lexus. But the Zombieverter, it's really a special type of design and really clever. It's supposed to work with all kinds of inverters and all kinds of motors, be it a Nissan Leaf or a Toyota Prius or a Lexus, what have you, and I don't even know what other ones could be incorporated in that. And that one also does more than just controlling the motor and the inverter. I think it may also control your charger. So it's a great device. It wasn't quite production ready or consumer ready at the time that I bought this. And I really like this unit, don't get me wrong. This is truly open source. You can change the code. You can change every line of code and make it do what you want it to do. So sky's the limit, and you will do that in Arduino using their programming language, which I think is C++ based. Anyway, don't want to get too deep in the weeds on that. So we've got our controller. This controller needs to control the inverter, and for that it needs to connect to it. Okay, so I brought out the harness here. This is the main engine bay wiring harness from Lexus. I think I paid $300, maybe $350 on eBay for it, or I may have found it at some local wreckers. Very hard to find. This connector here that connects into the inverter is unobtainium. We cannot find this, on Mauser or DigiKey. We cannot find this type of connector. One looks like it. I think it may be for the Prius or something like that. but it is not for this inverter. It might be actually for a Camry. So when you're buying this, be careful, and if they want to cut you off at pigtail, they usually cut it too short because of where it joins to the main wiring harness. And I know I'm really talking a lot about this wiring harness, and you think it's a waste of time, but this is so important, okay? You want it cut further down. You want maybe tell them 3 feet of it, if not 2 feet, but not like a foot, because they will cut off these special plugs that plug into the resolver cables that I've shown you before, okay? So as you can see, if you were to only cut off a foot, it will be nipped over here, and that's usually exactly where it's cut, because that's where it ties into the rest of the main body harness, if you will, in the engine bay. And I know these guys are lazy, and I'm sorry, but they don't want to unwrap it. It's probably not cost effective to unwrap it. But so I buy the whole thing, 300 bucks, best money I ever spent, saves you so much headache. Okay, so this here needs to connect to the controller. The inverter side is all 100% stock. That's the absolute beauty of paying the money for this harness and just getting it, okay? Because one side is completely done for you. So hopefully I don't make a fool out of myself. Okay, snaps right in, and that side connects right in there, and we get 2 of these resolver cables, all right? So we're going to start with these, and one is MG1 and one is MG2. And we are not going to connect MG1 to the resolver. We're not going to connect the inverter to the MG1 resolver, just like we did not connect MG1 high voltage to the transmission, okay, to the MG1 or the motor generator 1 in the transmission. Not needed for this simple test. Okay, so if I convinced you to drop 350 bucks on this harness here, there's more. I'm sorry, guys, but you got to drop another 300 on the transmission wiring harness, which Lexus calls engine wiring harness. So the first one is engine bay wiring harness. The second one is engine wiring harness. The engine wiring harness includes the 2 resolver cables that completely unplug from it at both ends. No need to cut a thing. It's awesome, okay? This is MG1 here, and we're not going to connect it, okay? So I'm going to throw that aside, keep it simple. MG2 will just snap right in. That's the beauty of it. So it will snap right in, okay? And this other end will run and connect to the side of the transmission. Okay, that's connected. Now you'll notice that we have additional wires coming from this MG2 connector for the resolver. These are power, and this is how we supply power to the inverter. Now you may ask, well, what's this doing, right? I mean, isn't this sending power to the inverter? Yes, but that's traction power to power the wheels. We need lower voltage to turn on the inverter and actually provide low voltage to the components, fragile electronic components that are inside it. We're not going to supply 360 volts to those components. All we need to do is give them 12. So this is why this part is part of the low voltage. So that will go to the regular car battery eventually. This we don't need. There are some additional wires on here that I still have dangling. There's a white wire with a black stripe. It's an extra wire. I should have just cut it off. And if you want more detail, if I'm going too fast, if it's not zoomed in close enough, if you can't really follow along, don't worry about it. There's another video that take you to the weeds on this stuff. And so this white and black wire is not needed. I also have multiple build threads on different forums that I discuss every single pin on every connector and every wire. There is also a black wire with a white stripe. So similarly, we just don't use those. So don't worry about those. And we're not going to use MG1, motor generator 1. So essentially what we're doing is we're going to run a test without recharging our car battery using what would be a alternator, okay? So we'll come back to this other wire. Then we have this big old strand. This is essentially 4 wires that have twisted pair in each one. I think there's 4 twisted pairs in each one of these cables. And that's the main connection to the controller right here. And I think this all goes to the B connector. Just snaps right in. And I just keep popping this out to show you guys what's going on here. This blue thing here is a Wi-Fi card. Okay, we can get our gauges, like our digital display, our gauges of, you know, motor RPM, temperatures, certain things like that. We'll talk about that later. But basically, now we've connected our brain to our muscle here. And there are, this, just like the inverter, needs 12 volts. So we have a red wire from this B plug. Just will simply run to our car battery, which I'm going to get next. Okay, so that will be connected to our battery. And it simply has a black wire. So this is the negative. So pretty much every component that we have to use will need to be powered on somehow. So our controller, red and black, run to the car battery, okay? Our inverter, there's red and blue, but they're both the same. I don't know why they did red and blue, but it just double wire to the positive on the battery. What I like to do is fuse my positive sides. This is just a simple blade fuse. It's a 2 amp. I usually start, if I don't know what I'm doing, which is, you know, 97% of the time, I'll start with a small fuse like a 1 amp fuse, and it will blow or not. You'd be surprised how little actual amps electronic components use. So I'll use a 1 amp, and if it blows, okay, I just pop in a 2. You run it on 2. There's no reason to put like a 20 amp in here or a 10 amp or even a 5 amp. Okay, so the lower the better, and if you blow it, just step it up, okay? So that's protected by a fuse. And almost forgot. So the inverter has negative lead as well that goes to a low voltage 12 volt car battery. It is a pair of white wires with a black stripe, okay? If you're specifically going to be doing a conversion using the same transmission. And again, my build threads have tables and pictures and close-ups, but basically 2 white and black wires are your negative. This red and blue pair is for the positive. Those will give 12 volts to the inverter. Controller, black and red, will get its 12 volts from the car battery. All right, what else do we have here? We have something that is important. There's some safety built into the controller. that will not try to power the transmission when we are not either in drive or in reverse. And for that, what we need is a wire that goes to the neutral safety switch on the transmission. Okay, and this also came from the same engine wire harness that is technically a transmission harness that I dropped another $200 on. So the resolver cables and the neutral safety switch came from that same harness. So you only need 2 wire harnesses from the factory, engine bay and engine wire, and that's about $600. Maybe you can find them for less, but it's worth it. You get those and everything just will plug in, and you're not chasing down automotive grade cables, worrying about color coding them, because you'll have to get spools of wire, you're going to have to get crimping tools, and you're going to need to get pins and terminals and all kinds of stuff, and plugs if you can find them. So we'll plug this in, and again, this will be telling our controller if we are in, let's say, park, it's not going to spin the wheels. We have to shift it into reverse, manually shift the transmission into reverse, and then it will spin the wheels in reverse. When we manually shift the transmission into drive, this will tell the controller, hey, we're in drive, it's okay to spin. When we put it in park, give it gas, nothing's going to happen. You know, if we put it in neutral, step on the throttle, nothing's going to happen. Okay, so I'm going to crawl under there and see if I can plug this into the neutral safety switch. And beautiful. Now, before I forget, this transmission is a unicorn on multiple levels. Obviously, it has 2 electric motors in it. It's essentially an engine or a motor. But also, it has 2 oil pumps in it, if you will, or 2 pumps for transmission fluid. Yeah, I believe it has one that's pretty much standard mechanical, and it was driven by the input shaft, which was driven by the engine, the gasoline-powered engine. Our engine is gone. We don't have a Lexus 6-cylinder here, so there's nothing to spin the mechanical pump. Okay, so we need to rely on the electric pump. So that's the second thing that makes this a unicorn, is that it has 2 oil pumps, if you will. One's internal, one's external. For the purposes of testing, keeping things simple, we are not wiring that external electric oil pump. We're only going to spin the wheels for a couple seconds. Should be okay, should be fine. We don't need that cooling at the moment, but that will be wired eventually. It has its own controller. For that, we do use the Lexus controller, the OEM controller, but this guy, this brain talks to that controller and manipulates it, if you will, and tricks it to thinking it's in a Lexus, and tells the oil pump how fast to pump or how much to pump. But anyway, I just want to put it out there. Okay, so at this point, we've wired our neutral safety switch. We've wired our MG2 resolver. We need to bring out the battery here. Oh, there's another very important component, and that is the throttle. Okay, so here I have a Bmw E46 Throttle Pedal, and the only reason I picked it is because monkey see, monkey do. I watched Damien McGuire's YouTube videos. Thank you, Damien, for all your work, research, reverse engineering, forward engineering, everything you've done and everything you continue to do for us. Really appreciate it. He uses an E46 pedal. He uses quite a bit of BMW components, and he uses different BMW pedals as well. Others will work. I like this pedal because all the electronics are integrated. Essentially, its brain is inside of it. I believe this is a Hall effect pedal. We only really need, I think, maybe 2 or 3 wires from this thing, but we're running more for redundancy. I think there's 2 channels in here for redundancy. We only use one of the 2 channels, but you could implement both, and I think that's a safety issue. So when buying your throttle, ask the sellers, if you're dealing with eBay, let's say, message them and ask them if they have a pigtail. Pigtail meaning a little strand. You can see there's some electrical tape right here. So I got about a foot of wire with this throttle pedal, and that's called a pigtail. And it gives you the plug, it gives you the wires, you can see the wire colors easier. It's just really nice to have. It will just snap right in. So here it is. Now, one of the reasons I wanted to do this test is to kind of check out my cable length. Now, I plan on mounting the controller inside the cab, but right now I'm kind of doing it out here. One is so it's easier for you guys to see, and 2, if I need to disconnect something quickly from the battery to kill power, I can do so. The vehicle is off the ground. Highly, highly recommended for this test. Do not try this with a vehicle on the ground. I've done some testing with the logic board here. Nothing wrong with the board, just my code, maybe the way I was configuring things. I went to make connections, hooked it up to battery, and my transmission started to spin. Sometimes you forget you left it in gear, it's not in neutral, it's not in park, it will spin. So if you try to connect everything and your vehicle is on the ground in your garage, you know, bad things could happen. So lift the wheels up just to be safe, okay? All right, so the throttle is connected. There are some additional connections here. With the 4 wires here, there was a 5th one running through there, and that is the park signal. I don't think we need to connect this. It's a safety thing, but I think we will be fine spinning when in drive or in reverse without connecting this. Oh, the other thing that we need to do is from the neutral safety switch, all right, there's a white wire here. That white wire is power. We need to give power to the neutral safety switch, believe it or not. So it needs 12 volts. So that will connect to our car battery. So I've mentioned this earlier, that all these electronic components need to be fed some electricity. Our controller gets 12 volts, inverter gets 12 volts, throttle pedal, believe it or not, gets, I want to say 5 volts, and it gets it through the controller. So it's sort of daisy chained up with this guy, but it still gets power. So like I said, you only need like 2 wires for the channel, 4 for 2 channels, but there's more wires than that because I think there's also a ground and a 5 volt wire going here from the controller. So that's how this gets its power. And the neutral safety switch on the transmission needs 12 volts as well. So let me get the car battery now. Okay, so I'm going to do a little rearranging here, and it's only to let you guys see better what's going on. Bear with me. I really hope none of this stuff falls off and I look like a fool here. Okay, so I'm going to start connecting things, and when we connect certain items, we will see something, and when we connect other things, we will not see anything or hear anything. But let's just, here we go. So I will take this out just for demonstration purposes. Hopefully I don't step on the lid. So black and red from the controller, okay, goes simply to the battery. So we have our positive, we have our negative. This is one of the things that happens. There's an LED here, which is nice. There's a blinking LED there. It's telling us that the Wi-Fi card is negotiating, talking, doing something. There are some extra wires here for later use off of the controller, just like they were some on the inverter. That's okay, all right? Okay, so at this point, only our controller is connected. Our inverter is not turned on at the moment, okay? Okay, so now, negative from the inverter to the negative, positive. This is one of those components that does nothing at this moment, okay? The inverter, powered up at low voltage, will not blink anything. It will not buzz, hum, or anything. It will once we give it high voltage. It will hum a little bit or buzz, but not yet. Okay, I just went and grabbed the red lead here to connect the neutral safety switch to the positive side here because it won't reach. So at this point, controller's powered on. The controller is powered on. The throttle pedal is powered on via the controller as daisy chain like Christmas trees. The inverter has power, and the neutral safety switch has power as well. What we need to do now is give high voltage to the inverter. I kind of want to do it so you guys can see this. Okay guys, so I had to kind of resituate myself here. I just wanted to connect things so that you can see them. So I've plugged this into an outlet and I'm going to power it on. And hopefully you can see these numbers. So the top line here says 31, so it's technically 30 volts. And right now it's not drawing any amps. It's like 0.027 or something. So I have the throttle in my hand. Hopefully we are in drive. And so, fingers crossed. Did you guys see that? I think we're spinning. Let me put you in a better spot. Okay, here we go. So what's happening, I think, is, because this is open diff, I think the other wheel is spinning. I'm going to see if I can wedge something under there. I wedged something underneath the other wheel. This is just, you know, American dependent rear suspension. Okay. I'm going to manually shift the transmission into reverse and we'll see what happens. Let me see if I understand this thing all being sideways. Where are you? There you are. Okay, 2 clicks because I think it went neutral and then drive. So we should spin backwards. And it's happening. And if you look at the, let's watch the digits, okay? I know we're going in reverse, but watch the amps. So it goes up there like 5 amps, whoop-de-doo. But I am really happy. This means it's working. So I'm going to turn everything off now. I know it's manual, but we're going to disconnect the grounds, disconnect the pluses. Well, I am super happy. That was a lot of work. Anyway, it's a good feeling. You know, what I'm trying to say is that you will do a lot of your work, all your heavy lifting prior to this point, okay? So this is like a dress rehearsal, but you've done all this stuff and you tested along the way to get here, and did all the wiring prior and, you know, tested before putting anything in the vehicle. It is a great feeling. Hope you found this video useful. Thanks for watching.